Right, so this diagram, this video is going to cover the case of a negative externality. They just call it an externality in chapter 16. And what I've started here is by considering a market, say the market for steel, because steel plants can generate some pollution. But what we've drawn up here is just the demand curve and the supply curve. So we'll assume we have a competitive market, a competitive supply of steel. And now we want to, and we've got the equilibrium that we would have in this market, the market clearing price, where the quantity demand is going to equal the quantity supply. And we have this drawn up here. Now, we want to start then is first discussing how we can add pollution, the effects of pollution into this supply and demand model. Now we know that the supply curve in a competitive industry is, especially the short run, is a summation of the marginal cost curves of the firm. So what you have here is like that would be the marginal cost curve. We can interpret the supply curve as a marginal cost curve. And I've added a P in there because that P is going to be private. Well, we're going to distinguish between private costs and social costs. And that's going to be the way we bring the externality in here. So the supply curve represents all of the costs that the makers of steel have to pay in the process of making steel. So they have to build a factory, they have smelters, and then they have to hire labor, and they have to have some iron ore, I think, that they use to make steel. And I think they're burning like coal or coke in the process. So all of the different things, including managers and everything, all of the different costs that a steel company would need to pay for, all of the inputs that they would need to pay for, are reflected here in the supply curve or the marginal private cost curve. Now the problem is we know that the steel plant has some smokestacks, and stuff comes out of the smokestacks, and especially depending on whether there's any pollution control technology in there, we could have some nasty things coming out of those smokestacks. We could have some things that could end up harming the environment, and that's not currently being represented in this diagram. So we have to think like, how are we going to think about this? Well, first off, the best way to think about this is that if you've got smoke and other pollutants coming out of a smokestack and going into the air, the way I like to think about this is that it's dirtying, it's polluting the air. But the better way to think about it is that this steel plant is using clean air as an input in the production of steel. And they're particularly using clean air as an input because alternatively you could have some kind of pollution control technology on that smokestack that would take all the harmful stuff, or maybe a lot of the harmful stuff, out of the gases as they come through the smokestack, and then they wouldn't be putting harmful gases into the air, and they wouldn't be polluting the air, so they wouldn't be using clean air as an input. So to some extent, I think that the way to think about pollution is that the firms end up using clean air or maybe clean water as an input in their production process. Now, that's not necessarily bad because although a lot of people would think like, oh, pollution harms the environment, and think that is like perhaps morally wrong. Well, the clean air would be a scarce good, and it would be like anything else. It's got competing uses. So we want to have clean air. We want to or clean water that we want to use, say for breathing, or if you're looking at views, you could also think of like haze as obstructing views. Or clean water could be used for drinking, could be used for swimming, it could be used for boating, and then also to sustain other types of life, aquatic life, for instance. So if the steel plants are polluting the air, they're using clean air as an input for this good in the production of steel. And that's costly. So if we want to think about it, there's got to be a cost in here that's not being represented. Well, if the steel companies' other costs of production are all expressed in, say, dollar terms here, then we need to express the pollution or the environmental cost in dollar terms too. So that's a whole issue in environmental economics, like how would you put a dollar value on the environment or damage to the environment. There are a lot of methodologies involved with that, and economists don't really have a problem. I think we can go about it and we can put a dollar value on that. When we've put a dollar value on this, then what we have to do is we have to add that to this cost of production. Right? That the steel plant is the cost that they have to pay for here aren't reflecting the full cost of producing steel. The way you can think of it is that there's got to be an extra cost, and that's the marginal external cost. There's a marginal external cost that's not being captured here in this diagram. We have to add it in here and then see how it's going to affect the diagram. Well, if it's a real cost and the damage to the environment is a real cost, and it's not included here, but we've got to add it on here. Well, if there's a cost we haven't included and we want to add it on, we would get a curve that would be shifting up. So just as if you think back when we introduced the supply curve, then we say like, oh, well, what happens if wages or the price of capital or prices of other inputs that a firm uses goes up? Well, if prices of inputs go up, the firm's costs rise, and so the supply curve shifts up. We have to draw a new curve in here that would represent the marginal private cost plus the marginal external cost. When we add those in here, we're going to get what we'll call the marginal social cost curve. Right. Marginal social cost. And use that term is this is the cost of society. This is the full cost. The pollution costs are real costs. They're not made up. They're not fake. They're real costs. They are part of the cost of production. We're using a scarce good, clean air or clean water, as an input in the production of this steel. We need to value that. We need to include that cost. We'll get the marginal social cost in that case. And the vertical distance between the MPC and the MSC curve, this would be the marginal external cost here. So the vertical distance between these two curves represents the cost of pollution and the marginal external cost. And since if you look at it carefully, the distance, the vertical distance between the supply curve and the marginal social cost curve is actually getting bigger. That's simply because we generally believe we live in a world of increasing marginal costs. So that would be appropriate to draw that. Now, that gives us a way of thinking about the cost of pollution, the external cost. Now we want to say, like, how does that affect the outcome here? Well, you have to think about efficiency. It's not going to affect the equilibrium at all, because if a steel companies don't have to worry about the stuff that they're putting, the pollutants that they're putting in the atmosphere, it's as if they get to use an input for free. So they'll look at their marginal private cost. So the equilibrium in the market isn't going to be adjusted, but the efficient quantity will be. Efficiency is going to involve is going to be where the marginal social costs are equal to the marginal benefits. The marginal benefits are actually here from the demand curve, so we can call that the marginal benefit curve. Or I actually like to call it the marginal social benefits curves. When I teach environmental economics, the takeaway lesson there is like efficiency is marginal social benefits equal marginal social costs. But in this case, I was just thinking of the marginal benefits. So efficiency is going to be here. The marginal social benefits equal marginal social costs equal marginal benefits. Marginal benefits are from the demand curve. The marginal social cost curve is the curve we've drawn in here to include the private costs plus the social costs. And so the efficient quantity in this market will be Q star. So that'll be the efficient quantity. And what we can see here is that the equilibrium quantity is greater than the efficient quantity. This is why an externality could be a source of market failure. We use the term market failure to refer to any case where the equilibrium is not efficient. And so here's a case where when we include all the costs, the full cost of the of producing steel, the efficient quantity of steel to produce would be Q star. We have too much steel being produced in equilibrium because really, if you think about the value to whoever's using the steel is given off the height of the demand curve. But the full cost of all the resources, everything we give up to produce that steel, is given by the height of the marginal social cost curve. So we can see at the equilibrium quantity that those last units of steel we produce aren't worth enough to justify their cost. Including all the costs, including the damage to the environment. So we, in the presence of pollution or an externality, we end up with markets would tend to, the equilibrium would tend to produce too much of the good. Another way we can see here is that if we took this quantity and said, well, what price would we need to have in the market to have the Q star be the quantity demanded by consumers? Well, we would take this point here and move over to the price axis, and that would give us P star, and that would be, in effect, the efficient price. And we can see that the efficient price is greater than the equilibrium price. And so that's another way to think about or interpret what's problematic about pollution, is that when the damage to the environment doesn't get priced into the price of the goods or services in the economy, then consumers aren't looking at the full cost. They're not bearing the full cost of what it is they're not bearing the full cost in what they end up consuming. We need a price that would reflect the full cost to society, and if we had that, it would be greater than the equilibrium price. So one way to think about the problem of pollution is that we would have too much of a good being produced, and the price of the good in the market would be too low because it's not reflecting the full cost. It's an important point to note here that the efficient quantity of pollution isn't going to be zero. So the problem is to solve the pollution problem from an economic standpoint isn't to say, oh, we can't have any pollution. Well, what we really want to do from an efficiency standpoint is we want to make sure that we're balancing the cost of using, say, clean air as an input in the production of steel with the other valuable uses of clean air, and doing that with other inputs as well. And when we do that, we would the problem is that in the market we would tend to have too much pollution. Not that we would have pollution, we have too much pollution. We have more pollution than would be efficient. So that's the way we would think about the externalities or pollution in a market economy.